Attendees are in listen-only mode.
Good afternoon, everyone, and welcome to ODTUG's online education series. Today's presentation is the Internet of Things and Oracle Database. This is a part of the 2017 CodeTalk series and will be presented by Blaine Carter of Oracle Corporation and Anton Nielsen of C2 Consulting. This presentation will be recorded and will be available to ODTUG members through the resources page of the ODTUG website by tomorrow. If you have a question during the presentation, please put it in the question box at any time, and the questions will be taken at the end. So welcome, Blaine and Anton, and thank you both for being here today.
Thanks a lot.
Thanks for having us.
So I guess we'll start off with my job at Oracle is I'm the open source developer advocate for open source technologies. It's kind of a broad position. I do a lot of stuff with whatever sounds fun at the moment. It's kind of a fun job, and lately I've been focusing on IoT and learning a lot there, and so I'll have a little project to show you that I'm working on here in a second. And Anton?
And I'm Anton Nielsen. I'm president of C2. I was at Oracle for about a decade. Before that I was a scientist in the Air Force, and I've done a lot of sort of front-edge technology work with the Oracle database and Oracle technologies, both at my career at Oracle and since starting C2. And a lot of what we've done at C2 is we have a group of folks that concentrate on custom solutions to companies for software you can't purchase off the shelf, which is, I suspect, a lot of what people on this call do. And one of those things tends to be in the space of interacting with hardware. We've done things with medical devices where the patient is hooked up to a medical device and we're monitoring patient statistics and vital signs and making real-time decisions on how to notify medical personnel about their condition, and other things of that nature. But real, good, important kind of work that needs to have robust, fast, really scalable technologies, and Oracle has been our go-to in that. When it comes to IoT specifically, recently I've been doing a number of presentations and training sessions around IoT. And that presentation really started when we purchased a Nest thermostat at our office. Folks are probably very familiar with it now, but we got an early Nest thermostat, and it sounded like a great idea, and for the first day we were really excited about it. But then we figured out that this is about what we could do with it. We could look at the temperature, set the temperature, and then do a little bit of reviewing of the schedule, those kinds of things. But really we were overall pretty unimpressed with our access to our own data, and even with its own algorithms. This was early days for Nest, and we weren't impressed with the ability to access and control it, though it had an incredibly nice form factor. And so we set out to say, well, how hard can it really be to do something like this? We've got a lot of experience in this space. For example, we built an airplane. We actually built that airplane on the left. It's outfitted with a whole bunch of sensors. That's probably 10 years old now, but a lot of the technologies are still there. In fact, we built the one on the right as well. The one on the right was significantly easier to build. But it demonstrates it's got a sensor on it. It demonstrates wing flex, and we often show this as a basic technology. So we got started on how do we essentially rebuild the concept of a Nest thermostat ourselves. And we went out, we did a quick little research on devices we might use and technologies. And within a week, we had come up with something. Perhaps the hardest part was actually doing the soldering for little pieces of it. So if you're going to do that, I recommend you get your 12-year-old daughter to do it instead of doing it yourself. She's probably much better at soldering than you, or at least much better than I am. She's got young eyes, nimble fingers, that kind of thing. Blaine can show off some of his soldering work, and perhaps we'll have a little contest, Blaine, to see who does better soldering, you or my daughter.
I'll bet it's probably her. Although I don't have to worry about my hair getting in the soldering.
Yeah, I know. Actually, slightly after that photo, I said, time to pull that back. So she actually went through and soldered up maybe 100 of these devices that we do a training class on, and I'm gonna briefly talk about that training class here. But we'll be doing a similar one at Kscope 2017 in San Antonio. A little plug for that, and you'll get to see similar to what we're talking about here, but a different device. So what we came out with is what we call the IOTemp, and it's just this device here. And I'll talk briefly about how it works, but the output you get is similar to what you might get from a Nest thermostat. You're able to control the device, and we actually have a device exactly like this running a fan in our server room to control the temperature, the AC unit in the server room, and we can monitor it and control it and report on it for as much time as we want to go back in history. So I'll talk just a little bit about that. The main thing is you've got a device and you want to capture some data and have it communicate, in our case with our Oracle database. Where else would you want the data really except in an Oracle database? So the architecture that we used, and this was a few years ago, and we may have chosen something different but if we did it today, but we're actually very happy with it. We implement the same architecture in a variety of ways. So how do we get the data from our device to our database and then control it? So what we did was we made use of a technology to get us connected to the Wi-Fi called an electric imp. And the electric imp itself is really that little SD card at the bottom of the picture. That's it's a little Wi-Fi circuit, as well as it's programmable, and it's programmable to be able to talk to the electric imp cloud. And the electric imp cloud has a lot of great little features, but it allows you to control and interact with this device. And this device requires very little power. It runs off a little USB battery or USB connection, and you can program it to do a number of things. Once it hooks up to the electric imp cloud, you can then essentially send the data or interact with the imp cloud in any way, any standard format. Of course, the real way to do these kinds of things is to use JSON and pass the JSON information from your device. So we used Oracle REST Data Services to interact with the imp cloud, passing JSON messages back and forth to control the device, and ultimately an Apex application to control it. And that's it. In 1 hour, you can wire up the device, build a REST Data Services service, build an Apex application. You can have the whole thing up and running in an hour. And we've got instructions on how to do that at this URL. It's conceptcompletion.com/IoT. Right there, everything you need is there to build this little device for yourself. So that's the class that we've been teaching, and we've got variations of it. And so I won't go through the whole thing on this conversation, but I do want to talk a little bit about showing this picture and running through the class is great, and it gives a great introduction. But in some ways, it's a disservice. It's a little bit like taking you out to surf and teaching you to surf on a little wave like this. You get a little push, you get a little wave, you're surfing in an hour, and it's a lot of fun. And then sending you out to surf in a hurricane. There's actually a lot that's going on there that we don't cover in 1 hour. And so it gives students a great opportunity to get in there, build something, play with it, and get a good understanding. But it leaves out a lot of the things that the imp cloud service does for you. Just a few of those are device virtualization, device management, messaging. I'll talk a little bit more about this and other things, but the device itself has to talk to something, and there are all kinds of methodologies that you can use to do that. That in our case, the imp cloud took care of for us. So I'm just going to give a brief idea of some of that. But before, I would say you could, for example, just use a Raspberry Pi or an Arduino. I think Lego Mindstorms allows you to do it. You can even hook up into your Roomba and communicate with it and pass information. You know, if you're using a Raspberry Pi, for example, it's got a Wi-Fi, or an Arduino, you can plug a Wi-Fi connection in. You could do all of that yourself, and you could avoid the Electric Imp cloud or the Oracle cloud. But when you do that, when you do this yourself, there are so many considerations to consider. So many things you have to consider. Managing software updates. If you have one device, that's not such a big deal. But often in this IoT space, you have thousands of devices roaming around in a variety of locations that you may want to be able to update all at once or have them automatically update. If you're Nest and you have to individually update every Nest that you've sold, that simply isn't a tenable business plan. You have to have a way to do these kinds of things. General security concerns across the board, the whole communications between the device and whatever you're talking to, you have to have those communications secured. You have to worry about the connectivity, Wi-Fi connectivity, or perhaps your device is Bluetooth. There may be firewalls in the way. Bidirectional communications is a huge thing, particularly when you're talking about across firewalls, because your device will either need to have some kind of connection through a firewall to your end source, or some other way to do bidirectional communication. And then concerns about message storms. If you have a number of devices and they send messages to each other that in turn do other messages, you can end up in circular messaging that just goes on forever. So some of you may have already seen, there's a great video of a gentleman set up his OK Google with his Echo Dot, and he essentially has Alexa set a reminder in OK Google, and that reminder tells Alexa to set a reminder, and then Alexa talks back to OK Google, and they go on forever. These are the kinds of things that you have to be concerned about with all of these kinds of devices. So I want to talk a little bit more about...
I'd like to jump in right there real quick, though.
Yeah, sure.
Don't let that... that's definitely what you need to consider as you're rolling out product, but don't let that anyway scare you away from digging in. When you first start, you can start with just a Raspberry Pi, and I got this. I got that off Amazon. It's got like 30 plugins for barometric pressure, temperature, IR, all kinds of stuff. It is so fun to play with this stuff.
That's a great point. I'll say you can go out to sparkfun.com and get a whole sensor kit for $40 or something in that range, $40, $50, that allows you to do all kinds of these kinds of sensors. We've got flex sensors, we've got relays, we've got temperature sensors, all of these things today. What we have sitting in our little lab space would have been $500,000 in product just 15 years ago, and now it's a couple $100 worth of products. It's amazing that the price of these things has just dropped.
Don't worry about burning something up. A lot of these things, you can get some really inexpensive devices, and if you burn them up, you buy a new one. And just watch out for deals. Where is it? So I needed a big capacitor, and so 10 of them was $1 more than one of them. So watch for those types of things. I'm sure I'll blow up most of those.
Absolutely. In fact, I found that pretty much across the board that 10 of something costs about less than twice than if you buy one. So if you've got a couple of friends that might be interested or something like that, buy a handful and share them, pass them along, or as Blaine will tell you, or myself, burn them up, because that happens as well. You get your soldering iron out, and before you know it, you're on your third temperature sensor, and still don't have it quite hooked up.
There's a bubble on the top, throw it away.
That's right. So that's a good point. A lot of these considerations that I'm talking about here are more when you're talking scaling, when you're talking about actually building something, not just to play with, but for your organization or for as a product. These are the kinds of things to consider. and so I'll briefly talk about a couple of architectures. One architecture is for your device to actually talk directly to your platform. You can, as I mentioned, you can talk directly to ORDS. You could go through the Oracle IoT Cloud Service. You can use Electric Imp. There are a number of these kinds of things. Firebase, Nest uses Firebase, I think. I think they still do. I'm not, they may have moved on. But there are a number of these services which you can make use of directly from your device. But some devices, well, and when you do that, typically the device itself has to be programmable, and often, if you're in the case of Electric Imp or the Oracle IoT Cloud, you're going to have some proprietary libraries that you load, whether it be C libraries or Java libraries. They tend to provide a few different options, but you have to have enough processing power and the capability on the device to talk with those libraries to the platform. The other architecture is that your devices can talk to a gateway, and your device perhaps your device can only talk JSON over Bluetooth. If you can only talk JSON over Bluetooth, you're not going to get to any of these platforms. You have to talk. You're going to have to get on the internet somehow. So another common architecture is that you have some sort of gateway device, and your smaller devices talk to that gateway, and then the gateway forwards it on to whatever platform you're using. So that's another common architectural platform. And then your gateway, of course, has to have those same capabilities. It's got to be able to run some Java classes or some C classes, whatever the platform requires. But those platforms, what they really do is they give you all of that manageability and an easy entry into the development lifecycle. So I'll talk a little bit about, just briefly, the Oracle IoT Cloud. The Oracle IoT Cloud allows you to talk to either a device or a gateway, but in either case, in either one, you have to use the Oracle's proprietary libraries, which they publish. You have access to them, and then once you've hooked up your device to your Oracle IoT Cloud, you have local storage. You can do everything on the Oracle IoT Cloud, or you can push from the cloud to any place else in the world, to your own on-premise Oracle database. You can use the Oracle database platform services for infrastructure or database. Once you've got the devices hooked into the Oracle IoT Cloud, it's very much like the Electric Imp Cloud. You can go to the rest of the world. The image there on the right is my nod to NASA's recent, pointing out that we've got a pretty hot planet these days. So that's where I picked that image up off of. But that's my only political statement of the conversation. But from there, I'm going to jump into a little bit more of just conversation, as well as I know Blaine has actually put together a presentation on how to create an ORDS service directly so that you can interact with it. So Blaine, I'm going to turn it over to you for a little bit.
Alrighty.
Conversation.
So I will also be at Kscope. If you want to unshare your desk, I will share mine. Where did I lost the control panel for desk sharing. I did this like 5 minutes ago. I've moved all my windows around. There we go. Show my screen. And let's show monitor 2. Okay, so can everybody see the screen with my pretty picture on it?
Looks good.
All right, I'm going to move that off, and I'll bring this on. So, like I mentioned, a lot of what I do is I find interesting open source technologies, and I try and help people get started. I have to learn it, and then I help people get started with those technologies. And of course, I'm always looking for something data related, so I can take advantage of the awesome data services I have access to. And the one that I found, that you can still see my camera here. So the project I'm going to be doing for Kscope is I've taken a kilowatt. Now this is not a project that I did. It's online. If you search for tweet a watt, then you'll find the project. What the original project does is you void the warranty on this device. You're going to be voiding a lot of warranties as you play with this stuff, and so you put some components in there that Anton had mentioned how to get data back to and from your devices. So I have this little thing here. It's called an XB. It has a little XB adapter board. This piece comes off so you can see just the XB transmitter. This is a little radio transmitter thing that plugs into this, which plugs into a USB cable, which I then plug into my computer. And if you can see the pictures here, this is just my tracking the project as I soldered it. So as you can see, my bad soldering job here, it's just fine. Go ahead and point and laugh. This is the backside. The Tweet a Watt project, if you go and look through, they have pictures of what the other side should look like. So I just took pictures of my poor soldering job.
If you want to send them over to Maya next time, she'll help you out.
Oh, all right, I'll send her a pile. One problem I did here, speaking of bad solder jobs, you can see how the pins don't go all the way in, and the second pin from the right is a little bit longer on the back end. That's because when I soldered the riser in that it plugs into, I overheated that particular pin, caused the solder to flow up into the hole, and so I'm kind of stuck. It doesn't fit very well. So I improvised. I took a pin, put it in my vice grips, put that pin in the hole, heated it back up, and pushed it down, and just little tiny burn on my thumb when I did that. But now it all seats better. This is the fully assembled device from the back and from the front, and yes, you can see very bad soldering jobs there. I have gone back and cleaned that up since then. Now the XB unit comes with this software here. This is how you connect to, so you plug the USB cable into your computer, and this allows you to make all of the settings with the XB unit. And that's showing that, yay, my solders actually worked and it connected. Now there are two pieces to this. There's a transmitter and a receiver. The receiver was the one that's on the USB cable. The transmitter that actually goes in the device has to be done a little differently, because we're actually going to piggyback on the power of the device and tap into the chip that's in there doing the power reading. So by the way, if you're not familiar with what a kilowatt does, you plug this into an outlet, and then you plug your computer, your stereo, something into here, and then the display will tell you how much energy you're using. What this project does is every 2 seconds it takes a sample, and the original Tweet a Watt project will tweet that out saying, I use this much power. I use this much power. That can be annoying to Twitter followers. So I plan to modify the software so that it instead uses ORDs to pass the data directly to my database. So this is, it's kind of ugly, but this is where we start to do it a little differently. Notice there's no center chip there. We're actually soldering in some resistors piggybacked on there, and then have to put in an extra capacitor LED. This is one of those monster capacitors I was talking about that we set up to put inside the device. That's what the transmitter looks like, or the adapter for the transmitter looks like once it's assembled. And then here is the inside of the kilowatt device, where you actually make the solder points directly to that chip there in the upper left-hand corner. That was probably the trickiest. Those little pins they're slightly bigger than like a push pin, but less than, say, a thumbtack. So they're little tiny things. And I recently got glasses so I could see those. And then there is plugging that back in, and the device assembled, not really stuck in. It's stuck in with mounting tape now, and of course I drilled the hole to put the LED out the end. There's a screen showing that it transmits back to the receiver, and we're back to the start. So now I have a device that tracks some kind of data. receives that data and does what with it. Rather than tweet it out, I decided to use ORDs, and I wanted to go through and just do a little demonstration to show you how easy it is to set up an ORDs RESTful service. Alright, so I will be using, I'm using an Exadata Express cloud account. That's one of the smallest cloud accounts we have available. It does come with ORDs set up, ready to go, and once you set that up, this is how you get it going. So you'll notice I have I've set up a new schema here just for this. We have no tables, so let's create a table. And I think I let my connection time out. Yeah, I did. So let's disconnect, and then we will connect. And all right, we'll pretend that didn't happen. If I let it, security reasons, of course, you got a timeout, so I let it sit too long. So new table. We just need a quick table here, so I like to name things simply, so we'll just call it quick table. We of course want an ID column that is a number, and we'll make it an identity column so we don't have to set up sequences and all that kind of stuff. And just for fun, we'll add 3 other columns. Fairly simple. Everything looks okay. I pre-wrote this insert statement here because you probably don't want to sit and watch me type all day long. So let's run that, and you'll see we have a row of data. I'm sure everybody just learned something there. Probably everybody knows how to make a table and insert a row of data. The things that you want to see, though, if you hit View and you go way down here to REST Data Services, and you click on Development, you'll get this new panel here. So this is the, call it a wizard, this is the tool for creating REST data services through SQL Developer. The first thing you need to do is you need a connection. So we are going to connect actually to, this is the connection to the ORDS server, or the the Apex where ORDS is installed, whichever way you have it configured. If you did the install, then you probably already know these 3 pieces of data: the host name, the port, and the server path. Of course, we're all using HTTPS for our things. Once we're done, we probably should talk a little bit about security, or the major lack thereof in IoT in general, that we all need to be working on. Give it any name you want. This is the username that you use to connect to your ORDS server, and then this is the schema that we just created that table in. Notice the leading and trailing slashes there. Alright, so we'll hit OK. I'll put in my super secret password. Hopefully I type it correctly. This little warning just says, hey, if you are working on something already, you're going to lose it, because we're going to refresh and retrieve whatever exists on the server. We should have nothing, so we can yes our way through that. And then as you can see, we have no modules. So we're going to right-click, create a new module, and this can be named anything you want. Doesn't really matter. This is just how you keep track of it. Now what we're doing here, you'll notice the example URL here. This is the URL that was in that connection data when we set up our connector, and we're going to create a RESTful service, and this level of the URL refers to a group of, let's call them endpoints. So keep in mind, I'm self-taught on almost everything that I do, so I will probably use the wrong words, and I'll probably say things incorrectly, but it will work when we get to the end. So this is a group of RESTful endpoints, or RESTful services, however you want to think of that. And so for fun, we'll just call it group. We do want to publish this, make it a RESTful service available for use. So check that, accept the pre-assigned stuff there. Now this is a little more specific. So if you're thinking of like the standard HR app that everybody's familiar with, that the demo app, if we were going to be building a RESTful service for that, the group you may call it HR, you may call it human resources, you can call it whatever you want. That's just a way to narrow down the focus of where you're trying to get. This particular piece is going to be focused at a specific object. So if you were writing RESTful services that are going to interact with, say, the person table or the department table, then this is the spot that goes to the object itself. So let's call this object. And notice I say object and not table. You can set your RESTful services up to run PL SQL or do whatever you want, so it doesn't necessarily have to match one-to-one to a table. This can be a general set of functions. To keep it simple, we're just going to run it to our table. I call it object, and you'll notice here, same URL, and it ends with /object. Keep the rest of that stuff there, hit next. Now with, we're going to be using the HTTP verbs, and with that we have 4 different options. We have get, put, post, and delete. Get is simply a retrieve me something from the web. Now as a RESTful developer, if your user is issuing a get statement, you need to write your service so they're not responsible for anything that happens. If you're doing updates or inserts or anything using a get statement and it breaks something, that's your fault as the person who sets up the REST service. It should implicitly be or explicitly be a safe way for them to get data. Let me shut that off. Now post is typically for people refer to it as inserting a record. Post more specifically is I have this object, this data object, and I do not know its ID. So I'm going to send this to the server. I want you to put this somewhere for me. And now in that case, going back to whose fault it is, if your user sends bad post data, that's their fault. This means the user needs to be aware that they are making a change. So post is typically meant for input because there's no ID usually associated with it. Put, on the other hand,
sort of as an aside, typically when you view a web page, you're doing a get. When you fill out a form on a web page and you click a button, you're doing a post. And it's really the same thing when you're talking about RESTful services. If you're looking to view something, typically that's a get. If you're looking to put something into the system, that's a post.
Right, right. And the 2 that you will not use typically with your web browser are put and delete. Put, a lot of people refer to it as updating a record, but more specifically, put is replace the entire record and given an ID. So if I have a record and I know its ID, I'm going to do a put. If I only want to update 2 columns, I still send all of the columns in because put is supposed to replace the entire record. Minor, nitpicky thing there, but just be aware that that's intended to replace the whole record. And delete's pretty obvious. It sends a delete to delete the record. So we're going to do a get first, and we have several options on how to set up getting our data from the database. We're going to just do a simple query, and we're going to return our data in JSON format. There's our summary. That looks good, and we'll set that. Now you'll see we have a module called anything you want. We have an object and a get. If you click on the get, it opens this little query window. This is the query that is going to run when the server receives the get. So we are going to select ID, column 1, column 2, column 3 from quick table. We'll just do order by ID. As with every other query, if you don't put in your order by, you get your order by however you get it. We'll run this really quick just to make sure that there's no typos in there. We got our row of data back. All right, so this is all set up and ready to go. You right-click your module and validate. Now this validate is doing a validate for the obvious problems. If my query were wrong and I hadn't already run it, this would say your query sucks. If its query is missing, it'll tell you you need to do that. So it's a high-level check. It's kind of a sanity check. So validate, and then we will hit upload. So now SQL Developer just pushed our new RESTful service to the ORD server. And I use this program called Arc. It's just a Chrome plugin. I've been using it for years. I kind of like it. This is the tool I use to test my RESTful services. This is the exact same URL that we saw at this level of the object level. Okay, there. And we're just going to issue a GET. Now you could type this into your browser and you would get back an ugly JSON screen. And we'll send this, and we got back a status 200. Okay, the 200 range of statuses is generally whatever you intended to do did not fail. 200 is the generic one. Okay, it worked. Now you'll see here we got back an array of items. Our array has one element. 0 is obviously the first one. There's our ID column 1, 2, and 3. And you'll see extra information down here with ORDs. Recommended practices for RESTful services. There's some control and additional information pieces that you should attach to your items. If you're building this REST service by hand, you should attach all of these things. And I'm not going to get into that. It's more of a discussion. But you should attach these other objects to all of your REST calls or your responses so that the client-side application knows what to do with the next step. So just know that that's what this is for. And that's the nice thing about ORDs is built following standard REST practices, and so it pre-builds a lot of that stuff for you. But anyway, there is our first record. So in a couple minutes, if you can't cut out all of my blah, 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 you have a GET service running. So now we want to do a POST. We want to get some data in. So you right-click on the object level. That's the template in is what they call it in SQL Developer. And you're add a handler. Now each URL, wherever it ends, can only have one of each of the 4 types. And we've already done GET, that's why it's grayed out. So we're going to create a POST. Now it's going to ask for a MIME type, and rather than try and type that correctly, I'll just copy it from here. This is not always required. Some browsers really want it, some tools really want it. I've never included this and had it break anything. I have not included it and had that break. So by default, if there's an option, I tend to throw that in there, and that makes things go. You'll see that was it for adding a post. We go into the post, and now it's ready to accept our change or code for changing. A key point with GET, you can do just SQL like I did, where I did the select from. With the other actions, when you're actually making a change in the database, it requires PL SQL, at least an anonymous block. And unless you really want to watch me type and retype and laugh, I'll just copy and paste this over. This is an example of what you can use for your PL SQL for the post. You'll see here we're declaring a new ID. It's a quick table ID type. We're going to do our insert statement using bind variables. We're all concerned about SQL injection, correct? We're going to return the ID into our new variable that we made, and then we're going to assign that value to an out parameter for new ID, and we're going to assign the out parameter of status to 201. Now, when I say out parameter, up here at the top you'll see a tab. If you want to return something extra back from like a put or a post or a delete, then you need to add your parameters here and let the service know how to handle it. So we're going to do a new ID. Now the name is what the user is going to see, or the client application will see returned back from the server. The bind parameter is what you see inside of your SQL. So this parameter here maps to this here. That way you can set it up to use different names in different places. If maybe you want to use camel case in your application side, say you're in Node or something, and you want to use underscore with your PL SQL. Of course, this is going to be an out parameter, and we want to put it in the response, and our data type is an integer. So that'll take care of returning the new ID when it's generated. The next thing that we want to do is we want to set the status. Now with Apex and ORDs, there are some pre-built parameters to allow you to control a few things. One of those things is status code. Okay, it's easier to type without talking. This is one of those control things. This allows you to set the status code that goes back. If you remember, I mentioned the code of 200. 201 is actually more precise for a post. That means just your thing worked and I created something new. And this is going to be an out parameter, and it's going to go into the header, so I'll leave that alone, and it's a string. All right, so that is our post object, and once again we want to validate. Go ahead.
I'll just mention that that discussion regarding those parameters is covered in the instructions that I provided earlier. So if you're watching this or if you're going back to it, and actually I can show those at the end. That whole discussion on that those parameters and what they mean and how they work is documented there. So you don't have to try and scribble it down right now.
And I am not a ORDS expert. I'm still learning this, but you know, I know enough to be dangerous. So this is the code I typically use most for that. We do want to validate. That works, and then we will upload it to the server, and that is up there. So now back to the ARC tool. We're going to switch over to a post, and I already typed this in ahead of time to, you know, because you don't want to see me type. This is the payload that we will be sending from the client application to the RESTful service that will go into the database. It's just a JSON key value object, column 1, 2, 3, A, B, all that stuff. So we'll hit send, and you'll see it worked pretty quick. We got a 201 created, and then our return value was our new ID of 2. So that will let the application know I created a record and its ID was 2. So that's a post. Pretty simple, pretty quick. Now, what if you want just one item? Because at this point, I'll notice also that between the put and the get and the post, I did not change the URL. We're still posting to the same RESTful endpoint. But if we do a get now, you'll see we have 2 records. If I want to display just a single record, we're going to need a slightly different template. So we're going to add a template to our module, and this pattern is going to be just a little bit different. We're still going to call it object because we're still talking about the same object, you know, whatever that is. Maybe it's person that we were talking about before, but now we want a specific one by ID. You can name the parameter whatever you want. You know, we talked about the parameter tab, but this is a nice, clean, RESTful way to get a specific object by ID. Leaving the other stuff as it was. Here I could do a query again, or I can query one row. Now when you're querying by ID, you probably will only ever have one row, so just to be safe, I like to pick that one, create that. You'll notice now we have another template here with our new get object by its ID. Just to save time, I'm going to copy the...
So, Blaine, maybe you know something I don't, but I would have put that ID in curly brackets. It's the colon ID. I've never done it that way.
The tutorial that I first ran a couple months ago did it that way, so that's the way I've always done it. Like I said, I'm no expert. I'm just getting started.
Well, if it works, then I've learned a different way. So.
Yeah, hopefully it still works. I ran this several times last night. We'll find out here in a second.
Yeah.
But yeah, good point. That's another good point. The things that I'm saying about how to use post, how to use put, which parameters to put them, you know, this is mostly opinion. There are no, you have to do it this way, everything blows up type of, well, there are very few rules like that. So this is just the standard way that I've always done it.
Okay.
It doesn't mean it's the right way. All right, so we do need to add in a where clause ID equals colon ID. So similar type of query, but now we're using the ID. Let's double check that. We'll get the one for value 2. Okay, our query works, and as always, we right-click our module, we hit validate, and that says it's good, and now we push that up to the server, and that's good. So now we are going to change our URL here slightly. We're going to say that I want object 2. So I'm going to put /2. I'm going to send my get. And once again, since it's a get, you could type this into a web browser and get back the same information. But you'll see now I got just the single object. I didn't get all the extra stuff, the control pieces at the bottom or the items array. This is a single record. And so I got the single record back. So now that we got a single record, let's update that record. And like I mentioned with put typically means you know what the primary key is, you know what the ID is, so put is more appropriately put in this area. So we're going to add and we're going to right click our object, add handler, click put. Once again, MIME type, safe than sorry, and I may even be typing that in wrong, but hey, it's, like I said, it works more often than it doesn't. And so we do that. It's very similar to the post. The put, the post, and the delete all use anonymous PL/SQL blocks, or you could call a built-in PL/SQL function, by the way, from your database if you would rather, if you have big fancy stuff that's going on. This doesn't have to all be done right in here. So once again, I had this already written, so I can copy and paste. It's a very simple statement. Update quick table, set the columns where ID equals ID. Notice I'm not changing the status. There is no specific code that says I did a put and it works. So I'm just going to leave it as the default 200. And I'm also not returning anything currently in this. Typically when I do a put, I like to return the new record, because your put may, you may have a last updated date and name column in the record, and you want to return that after all of the automated stuff happens. It's a good practice to build those same out parameters, just like I did with the ID and the post, and return the entire record, and it'll pop up in a JSON format. But for today, we will just put the data. That's fairly simple there. Validate and upload. And that says that worked. So now I'm going to modify record 2. I'm just going to leave that URL there. I'm going to do a put here, and I'm going to put an X here and an X there. Let's send that. That says, okay, it worked, and you'll notice there was no response. And that's okay. You don't have to get a response. Your application can just send it and say, hey, I hope it worked. Just to see that it's changed, let's get record 2, and you'll see that now it has the X's in the record. If we take off the record 2 and run the get them all, you can see records 1 and 2. Alright, so to wrap it up, last thing we want to do is we want to throw in a handler for delete. Same as before, just add the method handler for delete. And delete, once again, does require that you use the PL/SQL block. So here's a quick one here. Just delete from quick table where ID equals ID. Right click, validate. Right click, upload. It's uploaded. Switch over here. Now we want to do this by ID, so we're going to put in a /2. This time I'm going to put delete. And we're going to delete record 2. I got the status okay. I did not generate a response, so the response will be empty. That is expected. And then if we get all of our records, you can see that now we are down to 1 record. So that, if we cut out all of my blah, blah, blah in the middle of that, you can set up a fairly robust RESTful service for, control a table, however you want to do it. Take about 5-10 minutes once you've done it once or twice, and you can do this for any REST-enabled table in your, or ORDS-enabled table. I can't remember the exact terminology.
ORDS-enabled schema.
There you go. ORDS-enabled schema.
You can actually do a table by just right-clicking on the table. I don't generally recommend that, though. Then you just expose your whole table with no constraints around it. But if you really have a table that you just want to REST enable, you can right-click on it, and if you right-click on the table itself and say enable REST service, you could just do that, and it would automatically build a get and a post and a delete. But I don't recommend that. I would much rather see you do what Blaine did, and put in some controls around it. Otherwise, you've just opened up and if it's really what you want, you can do it, but you've just opened up your whole table to RESTful services doing any kind of updates on them.
Yep. So. And yeah, that's how I did it the first time, and then I had done it that way when I was trying to learn incorrectly while I was following the tutorial that was showing how to do it the way I just did it. This has been a few months ago, and so I did this, and of course nothing worked because when you let the wizard run it, it sets it up the way it wants it, not the way I was trying to do it.
Right.
So yeah. I like to do things myself. Anyway,
So,
that's
certainly if that's your goal, though, then go right ahead. So,
that is, I'll go ahead and stop showing my screen, I think there, and then move you guys back over here so I can see you. So that's how you set up ORDs, really quick and dirty. Do we have any questions?
So the box with sensors again. Somebody's asking if we can show the box with sensors again. I'm not sure which box they were talking about. I've got a couple of these. I've got this, maybe. Oh, there's.
Oh, I know what you're talking about. You're talking about.
There we go. Yeah.
Yeah. This is just one of the ones that are available. If you go to there's a lot of DIY.
SparkFun is one of them.
SparkFun, yeah. Just search for Raspberry Pi. Is Pi call them hats or shields? I always get that confused. I don't remember. Arduino and Raspberry Pi, they have the same concept. They plug in. I got toys scattered all over. So here's an Arduino, and you can see these risers on the side, the little things for plugging in the pins. They have other boards very similar, in fact exactly like this. So like the little XB thing, this would be what one of them calls them hats, one of them calls them shields. So this would be, this looks like a shield, so we'll call this a shield. That plugs in there. So if you search for Raspberry Pi hat, I believe it is, and if that doesn't get you any results, then search for Raspberry Pi shield, and you'll find all kinds of stuff out there. Just fun to play with. One project I've done with I've got Raspberry Pi scattered all throughout the house, hooked up to every TV. I have media servers. Search for Raspberry Pi Kodi, K-O-D-I, or XBMC, it used to be called, and you get a full entertainment system set up through a Raspberry Pi. That's kind of fun.
And we should definitely open it up if there are other questions. I think the moderator will pass those along to us.
While we're waiting, I did want to pop up the topic. We talked about security a little bit. One big problem in the IoT world, and this is spread throughout, I mean, no name calling or anything, but there have been some big name brands that have made some big time mistakes. Back in November, somebody took down a good portion of the internet. That was mostly because a certain company did not secure their interface. There was an IoT web interface to webcams and PVRs they had built, and so some bad guys took them over and made them part of a botnet. So thousands and thousands of webcams out there were DDoSing parts of the internet to take it down. There was the Nest, I don't think it was the Nest thermostat. One of the smart thermostats actually is vulnerable to ransomware. So, you know, they wait till it's 30 below zero, and then they take over your thermostat, they turn it off, and you either take it off the wall and put a regular one back on, or you pay them Bitcoin to turn it back on. That's also happened with smart TVs, all kinds of stuff. So when you add these IoT devices into your house and you allow them through your firewall to get to the internet, do a little research, make sure that they're at the very least using HTTPS. If they're broadcasting HTTP to the internet, don't use that device.
And certainly change any default passwords. That's a big part of the botnet problem, is people that put devices out and don't change their default passwords. That's you know, a common entry point for taking over your webcam or whatever else it might be. There is a question on getting some links on ORDs with RESTful service. I'm not quite sure what it means exactly. The Oracle website, if you just go to oracle.com and search for ORDs, you'll find the documentation on it. I'm going to just share the URL that I put up earlier so folks can see that. Let's see here. Share my screen.
Okay, I have a link to one of the tutorials that I first ran through. I will. You can see my Twitter handle there in my name. I will tweet that out as soon as we're done.
Yeah, and I've somehow lost the ability to share my screen, but the URL I shared earlier was concept2completion.com. That's concept, the number 2, completion.com. There we go. And /IoT. That's got the lesson that I was referencing earlier. And in there are a number of links to actually to components that you can purchase, places to get sensors and such cheaply, as well as some documentation on IoT and ORDs. So there's a fairly comprehensive lesson there for doing your first project. I'll point out that the same project can be repurposed to make a sous vide. My son did that. He's now able to cook the perfect steak in his homemade sous vide. A sous vide is essentially a device to heat water and keep it in a very precise temperature for cooking fancy whatever. And my son purchased a $20 crock pot and hooked it up with a relay and he's able to control his crock pot with an Apex application from his phone. And then, as I said, make the perfect steak. So there you go. There's that, if nothing else. Let's see if there's any other questions.
I haven't gotten any questions.
Okay, that's all right.
Feel free to hit either one of us up on Twitter if you think of questions later on, or send us an email. I think our emails are linked in here somewhere. I love to talk about this kind of stuff. I'm not. If you see I did something wrong, please let me know. I'm not afraid to be wrong. I just don't like to be wrong continually.
Yeah, certainly the same goes with me. If you've got any questions, I'm happy to answer them. You can, tag us in a tweet or drop us an email.
Look for us at Kscope.
That's right. So we'll both be there doing presentations. So great. And actually, what I would say, the one thing I would add is if folks are interested in playing with some of this, the Oracle makes a lot of free trials available. They don't currently have a free trial of their IoT cloud service. So I would suggest everyone drop an email asking for a free trial version of the IoT cloud service. Maybe if enough people ask for it, they'll put one out there. Great.
All right. Well, I just wanted to say thank you both to both of you, Blaine and Anton, for being with us today.
Oh, it was a lot of fun.
A lot of fun. Our pleasure. Thanks.
Great. Thank you. Have a nice day.
Thanks, you too.